Hello everyone, welcome back to the map of mathematics. In this video, we are going to solve this nice math Olympiad algebraic problem, and here we have a to the power of 24 plus a to the power of 16 equals to 36, and here we find the values of a. So here you just remember one thing is that our a belongs to R. So we just find the real values of a. So the very first thing we are going to do is here first we rewrite this equation as, so we break in the exponents of these two terms and we write it as, here you have 24 and we write it as a to the power of 8 and its whole cubed, plus we write this a to the power of 16 as a to the power of 8 and its whole square, and this whole equation becomes 36. So you see that we have a to the power of 8 be the common term, so that we will take here y equals to a to the power of 8. So when you substitute y equals a to the power of 8 in the above equation, so the above equation will becomes y cubed plus y squared equals to 36. So in the next step, here we obtain a cubic equation. So now we can make the factors of this cubic equation. So here we first rearrange the terms and we move 36 in the left hand side and we write it as y cubed plus y squared minus 36 equals to 0. So now we break its middle term and we easily get the factors of this cubic equation, so that here we write this y square as, write this y square as minus 3 times of y square plus 4 times of y square minus 36 equals to 0. So because here we have plus y square and we write it as minus 3y square plus 4y square, so it will becomes plus y square. So now we take common y square from the first two terms and it will be written as y square times of y minus 3, and here we take common 4 and you get y square minus 9 and this whole equals to 0. So here we use the nice square identity, and you know that if we have a square minus b square, it is equals to a minus b times of a plus b. So we use this square identity in the above term, and our above equation will becomes in this form: y square into y minus 3 plus 4 times of, first we write this equation as y square minus we write this 9 as 3 square and this whole equation equals to 0. So here we use this nice identity on this term and we write it as y square into y minus 3 plus 4 times of y square minus 3 square becomes y minus 3 times of y plus 3. So here we use this nice identity and this whole equals to 0. So here you see that we have y minus 3 be the common term from both of these terms and we write it as y minus 3 times of y square plus 4 times of, here we take common y minus 3 and we get y plus 3 and this whole equation equals to 0. So that in the next step we convert this equation into the two cases. So our first case is we write y minus 3 equals to 0 and the second case is we write y squared plus 4 times of y plus 3 equals to 0. So in the first case we easily get the value of y, so here we move this minus 3 to the right hand side and we get y equals to 3, and here we back substitute the value of y and you see that we will take our y equals to a to the power of 8, so we substitute this value of y here and you get a to the power of 8 equals to 3. So in the next step, So here we get a to the power of 8 equals to 3, but our target is to find the value of a. So here we take the eighth root on both of the sides and we write it as a to the power of 8 and its whole power 1 over 8 equals to 3 to the power of 1 over 8. So here you see that these 8 are cancelled out by this 8 and we get a equals to 3 to the power of 1 over 8. So this is the value of a. So now in order to find the other values of a, we need to solve this quadratic equation. Now first we write this equation into the standard form and we multiply this 4 on both of these terms and we write it as y squared plus 4 times of y plus 12 equals to 0. Here we need to find the real roots. So first we check is this quadratic equation has real roots or not by using the quadratic formula or sorry by using the discriminant formula. So you know that in order to use the discriminant formula, first we need the coefficients of this equation and these are a equals to 1, b equals to 4 and c equals to 12, and discriminant formula is written as delta equals to b squared minus 4 times of ac. So here this delta will becomes the value of b is 4 square minus 4 times of a is 1 and c is 12. So 4 square is 16 minus 4 times of 12 is equals to 48. So when you subtract 16 minus 48, then uh, you easily see that it is lesser than 0. So we know that if our delta is less than 0, it means that this quadratic equation has no real root. So if this quadratic equation has no real root, so that we will reject it this case, because in this question we need only real solution. So that here we have just only one solution of this equation, and this is a equals to 3 to the power of 8. So in the next step we will just check this solution. Is this solution satisfies our given question statement or not? So by checking, first we copy down the question statement and it is a to the power of 24 plus a to the power of 16 equals to 36. And now we substitute the value of a. So the value of a is 3 to the power of 1 over 8. We substitute it here and it will becomes 3 to the power of 1 over 8 and its whole power 24 plus 3 to the power of 1 over 8 and its whole power 16, and this whole equals to 36. So here we cancel these terms, so you see that 8 3s are 24 and 8 2s are 16, so that we will get 3 to the power of 3 plus 3 to the power of 2 equals to 36. So you see that 3 to the power of 3 will be equals to 27, 3 to the power 2 is 9, and this whole equals to 36. So it will becomes 36 equals to 36. So this shows that a equals to 3 to the power 1 over 8 satisfy the given question statement, and a equals to 3 to the power of 1 over 8 be the only real solution of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.